You may have heard it said that the brain is more plastic in early childhood. Well, what does this mean? It refers to the ability of the brain to modify itself and adapt to new experiences in the environment. Our brains have the greatest plasticity at the beginning of life, and it decreases as we age. This also means that the child's environment in the first few years of life has a very significant impact on how the brain develops and functions. Because infants are learning so much and establishing so many new connections between neurons, they have a great deal of flexibility, or neuroplasticity, in their brains. As we age, our brain doesn't make as many new connections. The plasticity of our brain is not as great as when we were children. This is the reason why it is so easy for children to learn new things, like a new language, which is considerably more difficult for adults. The brain's development unfolds in what is called a hierarchical order. This means that the networks that are forming in the brain begin with the most critical functions for survival in the world, such as seeing and hearing, and then move on to more complex functions, such as mathematics or complex problem solving. It's like building a house. You start with the foundation and other critical infrastructure like wiring, plumbing, and weight-bearing walls before painting and adding decorative touches. Because of the plasticity of the brain in early childhood and the fact that children's experiences in the world shape how their brains develop, the way we interact with children in our care is critically important. The quality and timing of the experiences we provide them can affect the structure of their brains for years to come. Let's learn more about the types and timing of experiences that influence the networks of neurons and their functions. In general, there are two different types of neuroplasticity: experience expectant and experience dependent. Experience expectant neuroplasticity refers to the connections being made in the brain that form based on exposure to experiences that most people or animals would have in their environment. Normal brain growth and development require exposure to these experiences. The brain is expecting these type of experiences. Experience-dependent neuroplasticity refers to changes in the brain's connections that happen only if the child receives the environmental stimuli to build those connections. The brain takes in these new experiences which trigger new connections. These are experiences that some people have, but others may not. For example, children living in an agricultural farm community develop awareness of weather patterns and responses of animals in ways that children growing up in urban environments do not. Another example is that children growing up in harsh, abusive homes learn to become vigilant to threat or danger in ways that children growing up in secure homes do not. Experience-dependent neuroplasticity is what allows us to learn and adapt to our environment. Scientists used to think that experience-based neuroplasticity stopped after early childhood, but they now know that that is not true. While the brain does become less plastic as we age, it does not stop. We can continue learning and adapting to our environment into adulthood. So we know that the timing of when a person is exposed to certain environmental stimuli can affect the development of neural connections. Scientists have identified that some areas of development have windows of time that close more quickly, often called critical periods, while others stay open longer, often called sensitive periods. Critical periods have more distinct windows of time when they start and stop. After the period ends, the window of opportunity for the skill to develop closes. Sensitive periods begin and end more gradually and represent the optimal time for maximum change. Although change can occur after the sensitive period ends, it just requires more effort. Animal studies have shown that there are certain windows of time during which the young are especially sensitive to their environment and are expecting certain input. For instance, newborn mice must experience normal whisker sensation in the first few days of life, or they will fail to develop normal sensitivity to touch in their faces. Cats must be exposed to normal visual input during the first 3 months, or their vision will be permanently impaired. Monkeys need consistent social contact during the first 6 months, or they will end up extremely emotionally disturbed. Many of these same periods appear to hold for human development, although we are less certain about their exact length. Babies require normal visual input, or they may suffer permanent impairment. Children born with crossed or lazy eyes will fail to develop sharp vision and depth perception if the problem is not promptly corrected. Language skills depend on verbal input, or sign language for babies with hearing impairments, in the first few years for the development of certain skills, particularly grammar and pronunciation. Without this input, language development may be permanently affected. The critical period for language learning begins around 5 years old and ends around puberty. This is why individuals who learn a new language after puberty almost always speak it with a foreign accent. Sensitive periods are the time in development when a brain region is most open to learning or refining a particular skill or brain function. Many new connections between neurons are formed during sensitive periods, and unneeded ones are eliminated, a process called pruning. Different parts of the brain have different sensitive periods based on when those regions of the brain are developing and maturing. For example, early in life, the sensory regions of the brain have a burst of synaptic growth. During the early months of life, sensory regions are being refined as a baby is flooded with new sensory experiences. Many new connections are forming between neurons in the sensory regions of the brain and body. Following the peak of synaptic development in the sensory regions of the brain, there's a period of great synaptic growth in the language regions of the brain. Following this period of language development is an even longer period for the development of higher cognitive functions, which extends well into the late teen years. Neuroscientists do not yet fully understand the biological basis of these critical and sensitive periods. One theory is that they correspond to periods of synaptic excess in the brain. As described earlier, there is a staggering number of brain connections being made in the early years, about 1 million new connections per second. In fact, the brain actually overproduces connections, some 50% more than will be preserved into adulthood. In this sense, a baby's brain is more densely packed with neural connections than is the brain of an adult. But having lots of neural connections isn't the goal. In fact, too many connections can cause the brain to operate inefficiently. Rather, it is having the optimal number of connections to allow the brain to do what it needs to do for a child to function well in his environment. This is why experience is so important. During the critical and sensitive periods, a child's experiences, sensory, motor, emotional, and intellectual, determine which of these synapses will be preserved. The least useful or least used connections are pruned or eliminated. Pruning is the process by which neural circuits are refined. Neural circuits and connections that fire more often or are used more often are retained, while those that are not used are removed. Pruning allows the brain circuits to run more efficiently. Early experiences affect the nature and quality of the brain's developing architecture by determining which circuits are retained and which are pruned through lack of use. In this way, each child's brain becomes better tuned to meet the challenges of his or her particular environment. Overproduction of synapses peaks in early childhood between 5 and 6 years old. Excess synapses are removed by pruning, which peaks in adolescence and continues into adulthood. As you can see, during the early years of brain development, the foundation for the architecture of the brain is being laid. It is solidified through the early experiences we provide for very young children, which influences whether the brain's architecture will be strong or fragile. This is why researchers believe that early childhood, particularly the first years of life, is a prime opportunity to positively enforce the course of a person's life. One very important way we apply this is by setting realistic expectations for the children in our care. For example, based on the timing of the development of the frontal lobe, we wouldn't expect a preschooler to have the kind of impulse control we'd expect of a second grader. Knowing that infants have rudimentary brain functions for attention, we wouldn't expect babies or even young toddlers to have long attention spans. Another important way we apply this is by being keenly aware of the importance of our interactions with children and the kinds of experiences we provide for them, because we are helping build the foundation of their brain architecture. They will build connections through their experiences with us that they will take with them forever. We also know that positive relationships and supportive, enriching environments that provide just right challenges, those that are tailored to the child's developmental stage and encourage a new skill development, help children learn and grow.